Thank you very much. Hello, everybody. I'll be talking about two things which we've been seeing as sort of the problems or challenges in this also agile world. While it's easy to put in new software to deploy quickly, the problem which we're having is testing quickly and efficiently, and then getting all these beautiful services which your customers are having on your old systems over to your wonderful new SDN environment. If you can't succeed in this, well, you're not going to make much money with the new stuff. So it's sort of a game changer to have an efficient migration. For that, I want to quickly just give a brief intro because this kind of technology is actually quite relevant. So there's a term called intent orchestration, which has been coming up in the industry. And the idea about intent-based orchestration is to replace classic programming template-based configuration by modeling, in which models constitute not just the object description, but also the business logic behind it. So we pack everything, the entire behavior, into machine-readable specifications. You know parts of it out of Yang, for example. Tosca does some parts of it as well. But this is a notion which is becoming fairly important. What do we do with a machine-readable specification? A machine-readable specification can be pulled into a system, and basically you have like an inventory which actually knows how it should behave, what it should be doing. It describes in all detail the behavior of your system, and when service requests come in, as you can see on this diagram, on the left-hand side, you build an impact model, so you identify and analyze what's going on, and you find out which of these services are affected, and then out of that you can then dynamically build workflows or action models on the fly in runtime. Okay? So what we're doing is we're putting every behavior of your network, of your services, into a machine-readable specification. That's quite relevant in the following parts. Testing. Let's go into testing first. So what we've been doing with customers is we had a problem in test cases, and in particular regression testing, because you have marketing and you have the engineering teams, you have the suppliers, they're all coming in with iterations very quickly. How do we get these test cases regression tested without too much of an effort? So what we've been doing is to take an example, we built an intent-based test model. So we have a test model which describes this entire business logic, and we configure the orchestrator. And then we first run recording phases with the configuration the way you would want it. And then when we put in the new system, we can actually then do a regression test phase where we then repeat the use cases based on the business logic, which is semantically machine readable, which means the system can generate automatically all the variations of the tests which you would want to do. This means you can have one use case, which will then generate 20 services, and out of these will be 300 or more service activations onto your SDN device. And then with this, you can do two things. So you have your test environment, so you can run regression testing of the services by testing the model against the orchestrator, so you know what services you're deploying. And you can do a regression of the network element. And one customer's project where we're having network elements or SDN controllers provided every month, instead of having lengthy manual test procedures, we continuously regression test within one day the entire SDN controller and as well the entire orchestration. So that no matter what, if you're changing anything north or south of your environment, you're reasonably fast up to speed on what's going on. Interesting enough, you can actually package these kind of test cases into Postman, the recordings, and you can send it to the R&D department of your supplier. That means you can actually have them regression test before the software hits your labs. The second, much more interesting case is the migration challenge. What's the problem? If we are migrating an MPLS network, we understand the core, we understand the edges, but the CPE devices, which constitute a huge volume of systems, they are unmanaged, uncontrolled, because in most cases, we have no service model in the OSS systems. They were always manually configured by your engineer on-prem. And you don't have a consistent configuration in terms of the configurations of the CLI systems itself. It was done, you know how it works. You deploy your CPE, you configure, oh, it works. Don't touch it. You're good with it now. Now, if you have 100,000 such devices in your network, how are you going to move these 100,000 configurations, each of them potentially different, into a consistent model so that you can configure your SDN? So the classic way of doing it is by getting lots of people and spending lots of time and many truckloads to go and do this configuration change. Not necessarily efficient, right? So the alternative is the following. We call it zero-touch migration. We say we take the legacy environment, we upload the legacy configurations, we translate the legacy configurations into a generic service model, which is agnostic to the supplier. And once you have a service model which is agnostic, well, it's a piece of cake pushing it down into your next generation SDN controllers. Not really rocket science, but how do we do it? So the first thing we do is we discover the configurations. So we pull out the CLI configurations that you can easily do offline. You pull out all the configs, and then you do something which is really fun. You run analytics over it. And when I mean running analytics, you'll see some slides on it. We actually try to analyze what the configurations are in the system and what the configurations are used for. As I mentioned, in this analytics, you find some interesting results. So with one customer, we identified more than 2,000 ways, 2,000, of configuring a single type of service. Not really surprising. Over the last 10 to 15 years, they've been engineers running around doing configurations, and as I said, when it doesn't work, when it works, they stop configuring. So you don't have consistency at all. And once we build that, we then build the service-independent model. We augment it with some additional information. VRF, for example, you won't find on the devices, and with that, you can then deploy it into a target model. The entire process we control over a migration order. What have we seen so far? We see that we can do lazy migrations with this approach. We pull up the data, we understand what to do, and then step by step, as part of your DevOps process, as part of your migration of legacy systems into the new environment, we're actually able to bring the legacy MPLS configurations across into the SD-WAN. Also very interesting is automated test and diagnostics, because once you have a service model, you can actually test the service model against the original system. How does it look like in details? Oh, I forgot this one, analytics. I like this one a lot because this came out as a result of our process in building the system. We found out that we can use the data, the CLI data, properly aggregated, to identify the use of the CLI systems, of the systems themselves. And we use this then afterwards to give the product managers an understanding what the customers are actually using their systems for. Today, product managers and telcos don't know what their CPEs are used for. You don't know. With this, we can find out what they're probably using it for. And we can also find out, as you see at the bottom, that you can do like site type analysis. You can find out what the probable use is for, and then you can start managing your migration strategy risks based on such an analysis. So what do we do? In the first step, we pull out the source configurations. We run it through a configuration parser, and we create two files. One is the device-compatible commands and one which are incompatible. Then we run it through current generation systems and translate it into Yang models. Out of that, we then do a resource discovery. And we create the resource structure, which consists of the Yang-generated models and the legacy incompatible commands, which the system wasn't able to understand. Mind you, some of these systems are 10 years old. Nobody was dreaming of Yang 10 years ago. We then use a model generator to build a proper intent-based model out of this, which augments the model with policies and business logic, which we found through the analysis. That creates a resource model. And in a further step of aggregation, we create a service model out of that. So that gives you the green part on the left-hand side, the legacy LAN model from the old vendor. On top of it, we have the service model, which is a generic abstraction model. And there are excellent examples in the market how service models should look like. And we provide that service model anyway as part of our deployments. And then we have the new model on the right-hand side, which is the new SD-WAN system. No matter which one it is, they're typically all equipped with excellent REST-based or Yang or other open API-based interfaces. And so the process is fairly straightforward. You load the data, you create for every object an instance model of your legacy configuration. You then pull this up into the service model at the top. You create your abstract service model. Out of that, you create the new resource configuration, and you pump this down into the new equipment. And since this is done piece by piece, you're fairly straightforward in managing the process of your migration. If it doesn't work out, you can roll back. You go only to blue, to the service model, and then you reconfigure the legacy existing system. You can do delta checking, find out if your service model actually would have resulted in a correct configuration. And so this finishes then off with what I call the orchestration process. By adding a migration process around it, you can then build first the discovery phase. And you see here a sample object model. So every orange box is a service configuration or a sub-service configuration. And you see here the containment hierarchy. So there's an interface consisting of IP configurations, consisting of address configurations, etc. And they all aggregate to a subnet service at the top. And then you translate this model into the service model for SDN. And now intent, this whole intent-based model comes to play. Because as you may remember, intent models, they contain policies, and they contain business rules, and they contain dependencies between all these orange little boxes. So the system at every point in time knows how it has to properly build such a service model. Sounds weird, but it actually is pretty straightforward. And once you have it running, you find out that you are extremely fast in building and designing such systems and also changing them on the fly. Our experience so far shows that about 80% of the service orders or migration orders which we would run can be done in self-service mode. This means that assuming you have 100,000 CPEs, 80,000 CPEs will be done without touching the system. You can go in, send the device to your on-site person, they do the deployment, we do the migration, that's it. 20% is something which we believe you want to have manual intervention, you want to have somebody around it because you need support, you believe this would be helpful for the implementation. If you calculate this, assuming 2 hours work or 3 hours work per intervention, you reach somewhere around 75% cost savings. And obviously time as well, because the faster you are in operation with your new SD-WAN, the faster you make money with your new services. The faster you're able to deploy UCPE, the faster you're able to bring in value-added services on top of it. And since connectivity is sort of the starting point for your new kinds of services going to market, I believe this is actually quite important. It's relevant, we believe it's relevant that you're able to bring new services into production quickly at as low risk as possible and with an excellent understanding of what the service models are that the customers are using. Because this way you can manage risk, and this way you can manage a customer expectation. In summary, we believe that intent-based orchestration as the foundation for this kind of approach can help not just in the classic way of doing DevOps and doing Agile and CI/CD. We see really two areas which are of added value, and the industry hasn't been thinking too much about it. First of all, it's testing. That's really the problem in day-to-day life engineers are confronted with, and if you don't do regression testing well, you run into difficulties. And the second is, as I said, migration. We believe with this kind of an approach, you can transform the way you've been doing migration. You get more information on what you actually have in your networks. And last but not least, you are actually able to start standardizing your service models. I don't know about you, but in my professional life, I had more than once a product manager wishing he would be able to have a standardized product model for all his customers, instead of having weirdo configurations for each and every individual. At least there's one guy nodding. I hope there will be others as well. So this is really something you don't think about, but with the approach, you actually are able to handle the complexity, the sheer volume of configurations you have in your network, and you're able to bring them into something which your product managers can make use of. Okay. And with that, I'd like to say thank you for your attention. And if you have any questions, just feel free to come over. Thank you.